Köszönjük szépen az előadást. Említettetek az előadás elején egy érdekes szókapcsolatot, amire ugye rá is kérdeztem.
Second language, right? So, but I must start by greeting you in Hungarian. Jó estét. After that, the only thing I know is that Bessel Angol. So I'll not continue with that. So my name is Godfrin Ismail. I come from Tata Consultant Services. I work as a generative AI engineer. So I'll present, my topic today will be about AI at the edge. Basically AI at the edge between innovation and regulation. And that is what I'll talk about. This topic is inspired me because in the midst of fear and motivation and everything, we found like a niche on how to work with here because I'm at the center of everything. So, okay, in the midst of the noise and everything about AI going around and the stories going around about AI, there are three key narratives that are going around. The first one is the political sphere of the narrative. So the guys or the people driving this fear proposes that the AI should be feared. Okay, actually, these are the guys that propose that AI will take our job. AI is there to control us. AI is there to bring things like dystopia. And also, people fear that it will be used for the whole wrong reasons like propaganda or driving some agenda. And then the other one is the skeptical part of the AI. And this one, we've seen it in schools and everywhere. People, students using it for the wrong reasons, perhaps the wrong reason. And I tend to believe that nowadays, if I was studying nowadays, I would be a very, very good student because everything is easy and everything is that. But also academic people fearing that AI will be, tends to hallucinate, tends to be biased, and it will promote ethical paralysis and make people not work hard. But in the midst of everything, the other sphere is the enterprise part of AI. Now, the one that actually, now the better side of AI, how to use AI in companies, how to make AI maximize on return on investments, and also how to properly govern AI so that it will give you proper investment, and also to see how to deploy it in devices, either at the edge or at cloud. And the whole of this presentation will be concerned with how to maintain the regulation part of AI, and also how to innovate boldly, and at the same time making sure that we are following in the lane of regulations. So, two architectures are driving AI in enterprises. The first one is the retrieval augmented generation, and the second one is the agentic AI, or basically the AI agents. I'm sure if you're in tech, you've come across AI agents. These are the key drivers of AI in enterprises. But in an enterprise environment, we suppose that AI cannot just be used we cannot take AI as machines or softwares that pass the Turing test, okay? But actually, we need to use AI in order to maximize on profits, and in order to, it's called return on investment, to maximize on the return on investment. So let's see how it's done. So the retrieval augmented generation, but I'll refer to it as RAG. I tend to use this example is that RAG is like a student going into an exam, an open book exam, which they have never studied for, but they end up passing. What do I mean by that is that you use an LLM, and LLM to mean large language model, you provide it with some context or data from in enterprise data or documents or historical data, and then it end up giving you secure and verifiable answers. On the other side, the agents are a bit more than that. They give you you give them some scoped autonomy. You leave them to work within some predefined workflow. And then for this one, examples of workflows that you can manage with agents are like ticket triaging, or in engineering processes like scheduling of tasks and scheduling of everything. And this one has been made easier by having LLMs that can run either locally or also on the server. If you're in tech, you might be familiar with things like LangChain and the provision of something like Olama that allows you to now retain an LLM and run it on the device. So, within all these ones, how do we now make sure that, yes, we are giving the agents our autonomy to run on their own, but how do we make sure that they're giving us not only the correct, we are not concerned about the correct output, but we are concerned about how they're getting to this output. Okay, can we see, is it a black box, or can we see that they are really getting to use the tools that we define them to use to tech, and also they are also in the confines of the procedures that we stipulated, and mostly these procedures are called guardrails. So the agent must be able to reason and also to plan, to reflect on their processes, and to be able to use strictly the tools that we gave them to use. And at the end, will you be asking the question like, did it halt with the correct output of what? How do you make sure that this one happens? Now, the mechanism to do this, to measure the relevance of the output and how it completed the task, are in things called evals, or evaluations actually. In evaluations, we will want to ask ourselves, did it complete the task first? And also, was the result compliant with the guardrails that we stipulated? And this has been what has gone on. And you realize that in the building of agents and retrieval augmented generation, mostly people have been doing prompt engineering until this new architectures came into place. New protocol called MCP, and it was actually introduced by Anthropic not long ago. MCP, or Model Control Protocol. This one lets you define the behavior, define what are the limits of that agent, and define the tests. The tests that are defining the evals, like did it complete or was it compliant? If you can see the representation here, you have the agent, yes, you gave it tools, you gave it the ability to plan, and you also gave it the ability to reflect on its own plan, and you passed it through the evals. Okay, but as we'll see later on, there are things that there are some malicious users that can prompt the AI badly and make it behave badly. But this one, at least MCP protocol, or model control protocol, comes up and tries to eliminate such things. So, I mentioned that there are problems that you can face, like malicious or something. So one of them is jailbreaking or adversarial prompts. This one, imagine you have like an agent that is in help desk, okay? But a chatbot in help desk, but a malicious user or another user tells it, write me a code to do this one. But it's a help desk agent, but somebody gives it a prompt like, write me a function that manipulates this one and this one. So that is not something that you can easily achieve, or it's not an exception that you can easily achieve or define in your own code. But this one has to be defined in the guardrails of the system itself. But how do you do that? Now, the biggest question here in agentic AI and the agentic framework is how to safeguard your own agents against such adversarial prompts, like the example I've given. Or another one is the context collapse in long agent threads. Like in long conversations, for example, if you've used ChatGPT, if you're a frequent user of ChatGPT, then you realize that you start it well, you start with it well and it's so good, but as you continue, it tends to forget some information that are up there, and then until you update it, so you realize it gives you wrong answers, not wrong answers, but it begins hallucinating in the middle until now you re-update the information. So that is one of the things. And then state corruption in persistent agents, like for example, if it was giving you the wrong things in previous conversations, how are you sure that now in the next things that the next conversations, maybe it can bring this corruption into the next things, okay? So these are the challenges of deployment of agents, apart from the challenges that come with the regulations that we will look at in the coming slides. But there are key trade-offs to consider while choosing what kind of models or LLMs to work with. Like sometimes it's best to do to build smaller models that, for example, if you have like an agent that scours documents to do with law, you never need something that is on the cloud or something. You can build just a local one that can scour quickly through the documents, or take an example of the healthcare applications. These ones tend to be more, we need more speed, and at the same time we need to maintain some privacy. Then the next one is power versus trust. Even though we need powerful models and trustable models, but we also have to make sure that they're not kind of a black box. We also have to make sure that we can trace from the beginning of its reasoning to how it went to the answer. And then hype versus impact of scoped delivery. Sometimes it's better to not just think in the general AI concept that we want an agent that can do everything, but it's better to just deploy an agent in one part of the workflow within the enterprise, and then deploy a smaller agent somewhere, and then make them work together. But you will agree with me that it's very, very hard to deploy a single agent. So multi-agent systems become now extraordinarily hard. So now I want to talk about innovation and regulation with regard to agents and agents architectures. So what is driving innovation is that companies or enterprises want autonomous agents, and they want to make sure that these agents can solve very, very complex workflows, but sometimes actually very complex workflows can be just reduced to a simple linear workflow. And also, we want things like custom copilots for our own use within the enterprise. But there is, to achieve that, you have to be compliant with several laws and fiduciary mechanisms that exist in the land. For example, the biggest one is the GDPR, Data Protection Act, that we want to make sure that the data that you're using, for example, if you're using user data, then it's never leaving the device, it's on device only. And then later on, we'll talk about the EU AI Act that stipulates or comes up with the pyramid of tiers that regulates what kind of AI system can be built, and basically a classification of the risk of AI systems. We'll look at them some point later. Then we've talked about responsibility, and I've also mentioned explainability. These are not the same things. While responsibility focuses on things like deploying ethically, fair, and accountable and transparent AI system, on the other hand, explainability needs that we can peek under the hood of an AI system and actually see how, or trace how it began the decision and how it actually reached to that decision. For example, if an AI system, you could build an AI system for hiring people, so it should tell you explainability will require that it will tell you how it reached to the decision of hiring such a person. But responsibility will make sure that it never factored in historical injustice factors of some race or something towards the goal of hiring such a person. So there's responsibility and explainability sometimes can be confused as one term, but one thing, but they are different as such. So this one now leads us to the classification that I talked about. The EU AI Act classifies AI systems, and in these systems, I'm talking about the soft AI systems. You can think of them as the chatbots and not the complex ones, or like the autonomous cars and such, or the robots in the manufacturing companies. So at the bottom one is the minimal risk AI system. What are these ones? This one could be something like a spam filter on your email. That is something that can be deployed freely and you can use it freely. But the second one, the second tier, consists of now mostly chatbots, systems that can be manipulated to do some other thing. Okay? For the systems in the second limited risk tier, if you're developing such a system, then you have to inform the user, the person that is using the system, that indeed they're using an AI system. And then the third one is the high risk AI system. Now, these ones are systems that are a bit critical. Systems like those ones you can use in the law sector or in the hiring of people. And then the unacceptable risk now, they are systems that they're not yet allowed to be used, like the surveillance system, the facial recognition system that surveils people in real time, or systems that can manipulate children doing some things. So these ones are unacceptable. So before you go ahead to build one, you must properly classify your system and to be lying in which one amongst these ones. So now, what will be the future of explainability? Where are we heading from? Where do we go from here? In the midst of having new methods coming up to make sure that there's explainability, you can also achieve it by building actually a decision tree that shows you how the pathways of decisions of the model. But the ultimate goal is to make sure that we're building systems that are powerful, and at the same time, they are very, very transparent, and they are trustworthy. So this one leads us to a refrain and sort of a rhetorical question that do you guys see if AI systems are good or there are potential threats? Or how should governments and industries regulate AI responsibly? And should they even regulate it at all? Or what are the most exciting developments you look forward to in AI? These are rhetorical. They don't need an answer. And then as a final reflection, when ChatGPT was coming up, somebody said that he uses it he exports the labor to ChatGPT and retains the brain. So, and he said, we don't need AI that is smarter than us, but we need an AI that works with us within the boundaries that we define it to work with. And this guy was Yann LeCun. Yann LeCun works at Meta right now, previously called Facebook. He said, our intelligence is what makes us human, and AI is an extension of that quality. And that artificial intelligence is extending what we can do with our abilities. In that way, it's letting us become more human. And actually, over the years, we've seen that AI itself, what will happen is that job portfolios or job descriptions have to be changed to accommodate what people can do with AI. And how it can enhance everybody. So thank you so much.